Very innocent looking, very simple looking question. You are asked to find out C by R, but then there is a difficulty coming. You are asked to find out C by R. Can we take this as a simple closed loop path? No, because there is the presence of this. Similarly, can I take, or else can I take this as a path? G1 and H2 together? No, there is this summation point coming in, which means you have to either change this, take this point somewhere, or take this point somewhere. In any manner you can do. You can take this takeoff point after G2. Takeoff point after G2 can be taken, in which case this will become equal to G1, G2, H1, H2. This will not remain as H2, as you know. This will not remain as H2. It will become, because I am taking it, because I am taking this takeoff point after G2, our takeoff point after G2 will be multiplied by 1 by G. Takeoff point, this ahead, and always remember, I want all of you to remember the takeoff point ahead multiplied by G. Takeoff point, I am taking this after G2. So this will become H2 by G2. Negative sign, positive sign, positive sign, negative sign. Okay, this is one method. Now you have a case where you can use these. H1 and G2 can be reduced. Further, the total can be reduced. Or else, another alternative will be, in this case, I told you either the takeoff point should be taken away, taken to some other location, or the summation point. If I can bring the summation point to another side also, I can do. I can even take this summation point somewhere ahead of G1. Somewhere ahead of G1 will, so that I will get this as G1. I'll have one summer, which is this summer. Whatever summer that I have taken ahead, that will also be there. Now I don't have the summer again there. I'll have only G2 and this. This summer has already come here, which means my H1 will be connected like this, and my H2 as before. This is plus minus, plus minus. Now, again, I can always interchange between these two, or as someone asked yesterday, I can always make this as a single this thing, which means I can combine G1, G2, H1, or first I can combine G1 and H2, then I can combine the whole thing together. I should get the same answer. But one more thing that you have to remember is, when I put H1 here, I have one more block, one more thing coming up, because I have shifted that, isn't it? So there, the block will not be H1 anymore, because I am taking this summer before G1, summer before G, summer ahead of G1 means I have to multiply by 1 by G1, H1 by G1. This will be the case. I'll give you the answer. In whichever way you do, either cheyidalum, finally you will get C by R is equal to G1 G2 by 1 plus G1 H2 plus G2 H1. This is a final answer. This you should get. I will tell you a very, very secret thing. When you get a block diagram reduction question, you have to do all these things, but finally you can verify whether your answer is right or wrong. That is all you should do. This is something that I have found out because of years of experience, or maybe years of doing this, or else maybe it can strike to you also. Whenever this question is coming, you can straight away understand this will be the answer, because you just look into the numerator. Whatever things are coming in the numerator will be those in the forward parts. G1, G2 divided by one path, even whatever is there, let that be there. 1 plus G1, H2, one path is, one loop is there. G2, H2, H1 loop is there. You can verify this with all the problems that we have done in the previously. All the 4 other problems also. You will see that finally this will be the way in which the answer comes. This I have told you only for verification purpose. Okay? Only for verification purpose. Now, what we dealt with till now was block diagram reduction method, and we saw that any complex diagrams can be reduced block diagram by block diagram reduction method to a single block where you have a single input, single output. You will have C and R, and whatever single value that you get will be the transfer function. But then you saw it is a complicated thing. But just because I gave you this mantra, this secret GRB mantra, it may be a little more easier for you. Because always you have to remember takeoff point. And ahead multiply by G. Takeoff point ahead multiply by G. Takeoff point after means going to the right, after multiply by 1 by G. Summer ahead multiply by 1 by G. Summer after multiply by G. This is all you have to remember. Then second thing that you have to remember is, if you have two blocks coming like this, G1 and G2 coming in, you can reduce them as G1, G2. CR. Third thing that you have to remember is, if there are blocks coming like this, G1, G2, coming to a single summer like this with positive, negative, and they are starting from the same point. They should start from the same point, then you can write this as, sorry, CR, I forgot. RC. Then you can simplify that as a single block where you have R and C. This will be G1 minus G2. But remember, always remember, people always go wrong here. They should start from the same takeoff point. If not, make necessary corrections. Ee moonu karyam. 1, 2, and 3. If you can remember these 3 things, block diagram reduction method is useful. It can be done very easily. I have one more problem with me, which I will write as a note and circulate to you. Okay, I'm not giving you. And if you have any doubts there, we'll discuss that also. I don't want to spend more time on block diagram reduction method. Now, what I want to tell you is, you have seen that block diagram reduction method, though it is useful, it is having a number of steps. We need to spend a lot of time in that. It's and you have to go on redrawing this block diagram again and again. It is a tedious process. If it is a very complex block diagram, it is a tedious process. So someone called Mason has come up with another method called signal flow graph.